example 2, they give us the graph of f of x, and they want us to sketch the graph of y plus 4 equals f 1/2 x plus 1. So a couple things on this graph. First of all, on the original graph, if you have your red pen, I'd like you to add the asymptotes and label them. Secondly, we have worked almost exclusively with the y by itself, so I am going to get you to move the plus 4 to the other side as a minus 4. In other words, subtract 4 on both sides. We're going to make a note just to remind ourselves we thought about this. We noticed that it's already in factored form, which is nice. So once the 4 is onto the other side and we notice that it's already in factored form, now we can go across and say, I recognize this. This is inside the function. It's going to be a horizontal compression. No, horizontal, because we're going to be multiplying by 2. It's a horizontal stretch. What's the 1 going to do? Since it's already in factored form, this 1 is going to move it 1 to the left. So that is a horizontal translation. And this is a vertical translation, 4 down. This horizontal stretch, underneath it I can write, we're going to multiply our x values by 2. The graph gave us 2 values. It gave us 2, -0.5, and -2, -0.5, so we'll use the values they gave us. And since we have stretches and translations, we will have 2 sets of arrows and brackets. Above our first set of arrows is where we deal with all of our stretches, compressions, reflections, and we just have 1. Then we're multiplying x by 2. In the second set of arrows, that's where we do all of our translations, and this one we have 2. We're going to go 1 to the left and 4 down. So, 1 to the left and 4 down. And so now here the y values aren't changing at first, so we'll still have 0.5 and 0.5. But our x values are multiplied by 2, so we'll have 4 and -4. And then we need to move 1 to the left. So this will become 3, and this will become -5. And 4 down will make this to -3.5 and -4.5. The other thing that we're going to do is if we have an equation that has asymptotes, and ours does, it has 2 of them, x equals 0 and y equals 0, we're going to find out that the only thing that affects an asymptote is moving things left and right, especially if it's at 0, or only if it's at 0 actually. If something's at x equals 0 and you multiply it by 5, it's still going to be at 0. But moving it left and right and up and down will change it. So the fact that I started with x equals 0 and I moved 1 to the left means my asymptote's going to get changed to x equals -1. And the fact that I started at y equals 0 and moved it 4 down means that my asymptote is going to get changed to y equals -4. So now on a separate graph, I'm going to graph my equation. I'm going to start by drawing in my asymptotes. just so that your original graph doesn't get too busy. I sometimes find if I put everything on the same graph, all those asymptotes get mixed up and it's a little bit hard for me to see which asymptote was part of my original graph, which one's from my next one. And it's not hard to picture them from looking at one and looking at the other. 1, 2, 3, 4. Y equals -4, x equals -1. Label both my asymptotes. Now I can go and plug my points in. I have 3, comma -3.5. And I have -5. Comma -4.5. And I have my final graph. Did anybody recognize what the original graph actually was? It was one of our parent graphs. What's the equation of our original red graph? It's a 1/x graph. So what is the equation of our blue graph? In other words, in terms of x. So again, I'm talking this language. The equation of our blue graph, if our red graph is y equals f of x, and we know that f of x is 1/x, our blue graph in terms of f was y equals f of 1/2 x plus 1 minus 4. That's the equation of our blue graph in terms of f. If we want to find the equation of our blue graph in terms of x, we need to change this function notation into explicit notation. How do functions work? Well, inside my function, I'll highlight it here in yellow. This is what or green. This is what I have inside my function. And function notation says whatever you have inside of your function replaces the x. So the equation of my blue graph in explicit notation is 1 over, and all of this inside replaces the x, and then outside I still have a -4. I know that changing from function notation to the explicit notation in terms of x, that takes some practice. So that's why I'm doing that. Whenever we have a graph that I know that we can do that with, I'll show you that so you can continually think about it and see if that makes sense to you. Questions for practice, brought to you by our sponsor, 7-Eleven.